Alright students, thanks for watching. This video is going to go over Math 3 section 4.1. The core concept is rational exponents, but what that really means to us is radicals. So let's break this down. Rational actually means fraction. It means rational is a ratio, which is a fraction, and the fractions end up being square roots. Now, if you can read all this and understand it, then you don't need to be watching this video. Go ahead and move along. Have a wonderful career in math. I'm sure you're going to be a math major and graduate in 3 years instead of 4. Now, this is not easy stuff to read. That's why we're here. That's why we want to try and break it down. So the core concept is you're going to have a fraction as an exponent, a fractional exponent. All right. So let's generalize this. Let's make it a little bit easier. Let's just start with x to the 1 over n. By definition, if you have a fractional exponent, by definition, you can rewrite it as a radical. Okay, that's the rule. And we can go through that maybe in another video, but for now we just want to talk about the mechanics, how to actually use this. We won't talk about why it actually is that, but the rule is now, if you have a fractional exponent, it's a square root. Well, not a square root. In this case, it has n on the bottom. That is a nth root. The nth root of x to the 1. That's by definition how this works. Okay. So usually we're used to square roots. We know square roots. Like square root of 9 is 3. Okay. But some people don't. So let's talk about that. Why is square root of 9 3? Well, because the square root of 9 can be rewritten as 3 squared. And in a square root, there's an index of 2 here. We don't usually write it. Okay. Your calculator, if you have a button for it, usually doesn't put it. Okay. But what it is those things are opposites. The square root of the square cancels. You're just left with 3. Okay, you're left with what's inside. Okay. So that's a big idea for what we're trying to do here. Okay. And then what we'll have is, of course, the book will change it, and you'll have not just a 1 on top, you'll have other numbers. Okay, so that's what we want to try and figure out today, and do actual numbers. We're just going to jump right into it with 27 to the 2/3 power. What in the heck? Okay, so you could do this on your calculator. Okay, just a quick side note: on some calculators, if you're or on the computer even, if you're typing it in, you need to put parentheses around this exponent, because this whole thing is the exponent. Otherwise, your calculator will do 27 to the 2, find that answer divided by 3. So you want it to the 2/3 power. That's if you're doing it on the calculator. But you're not going to check that yet. And the whole point of this video is to help you out, so you're not relying on the calculator. So first things first, you know you have a radical. That's the rule. 27 goes inside. 3 is what we call the index. 3, you have to make sure that is, and it's always this, the denominator becomes the index. The numerator, that 2, is the exponent. Alrighty. Now you're like, well, you said without a calculator. I'm pretty sure we're going to need a calculator here, because 27 squared is 729. So I could square that, but now I think, oh, geez, that's not really what I want. So let's try it another way. That's sort of what the book does also. You need to sort of know your rules of exponents. Okay, and we'll review them, of course. That's what we're here for. Okay. Do you have 27? Ah, crap. Let me rewrite it this way. I want the 1/3 inside the parentheses. See if you agree with this. Based on the rules of exponents, based on the rules of exponents, 27 to the 1/3 raised to the 2. The rule of exponents says you'd multiply these, so 2 times 1/3 would be 2/3. This is technically the same. Okay, you will get the same answer here. So these are both the same. Here's what I'm going to write. I'm going to change this to 3rd root of 27. I know it's to the 1, but to the 1 power raised to the 2nd power. The 3rd root of 27. All right. So these are actually technically the same. Okay. I followed a different path to get here, but The book shows that, and you're like, wait, why is it that they put the 2 outside or they put the 2 inside and it doesn't make a difference? Well, depending on which path you take, and depending on which numbers inside, that sometimes will help. Okay. So let me rewrite this. Let me move the camera down. That's where we're at now. The third root of 27, and we're going to square that. So let's break this down here. 27 happens to be a perfect cube. How do you know that? Well, you've got to do what we call a factor tree. 27 doesn't have many factors. It's 3 times 9. But 9 is 3 times 3. And you can't break down 3 any smaller. It's just 1 times 3. So 27 is really, if you go down to the bottom rows here, 3 times 3 times 3. In other words, 27 is actually 3 to the third. So that's the trick we're going to use here a lot. 27 is 3 to the third. Now what this does is the third root of 3 to the third cancels. And you just have 3 inside. But wait, there's still a 2. And so you get a 9. What the heck? So going back through all this stuff, we said 27 to the 2/3 equals 9. And yes, you could do this on the calculator, but it would never make sense. Why are you getting 9? I don't see how I know 9 is a multiple of, or a factor of 27, but I don't see how you get that out of the 2/3. It's not clear. You could divide the two. No, that wouldn't work. Yeah, it's not clear. So let's just work through more examples like that, and that's what we'll practice. Okay. Okay, this will be example 2. 4 to the 3 halves. Let me get it. You got to get your brain not to think of it as 4 times 3 halves. It's 4 to the 3 halves, and there, like I said, there's different ways to do this. That's the square root of 4 to the third. In this case, 4 to the third, I know is 4 times 4 times 4. It ends up being 64. And I happen to know the square root of 64 is 8, because 8 squared is 64. So some of these you get to kind of quicker. And a big part of this, as I'm sure you've heard me say in class, is practice, practice, practice. Okay? Knowing that it's 4 to the third is 64, most people don't know that. Okay? I know it because I do these problems all day long. So have a calculator to help you out with some of them, but try and follow with scratch paper. Do this logic, because I cannot do this in my head. Okay? So you got to use scratch paper. Let's go through this one more way, though. What if you didn't want to do the 4 to the third? You say, I got confused right there. Remember, this is the same as 4 to the 1/2 raised to the third. You can change the rules of exponents. You can split that exponent. 3 halves is the same as 3 times 1/2. Why is that easier? I'm not sure it is, but then you can do the inside part first. Okay, and again, the reason this works out, the square root of 4 is 2, because if we rewrote 4 as 2 squared, that cancels that. And so you get, inside you get 2, outside you get 3, so 2 to the third is 8. So we get the same answer we got that way as if we did this way. We get the same answer both ways. Alright. And that's, like I said, that's really just a part of it. So let's choose one more example from a book, and we'll wrap up the video. Alright, so this is taken directly from the textbook. And you might be worried you have a negative in here. We'll get to that in a moment. First, though, let's say, okay, 64 to the 4/3, that's the third root of 64. I can put the 4 inside or the 4 outside. I'm going to put the 4 outside. Because if I do 64 to the 4th power, that's this. 16 million something. I'm not going to try and factor 16 million. That's insane. So don't do that, okay? So again, I'm allowed to do this because it's negative 64. If I rewrite it like that, that's 64 to the 1/3 raised to the 4th, which is the same thing, then what's in parentheses is this, the third root of 64. Okay, now how do you break down 64? Well, we happen to see 64 in the last problem. Let's just assume you hadn't done that problem previous, if you didn't recognize 64. You can do a factor tree, but 64 is kind of big. It has a lot of factors. You need something that's a perfect third. So over here, I'm going to make my small list of cubes. And it's good to have this list written down on a piece of paper somewhere, and then certain numbers you'll come up with a lot. You'll come across them a lot. And if you ever need it on a test or something, you can generate it just by following this down. 1 cube, 2 cube, 3 cube. 1 cubed is 1 times 1 times 1, that's 1. 2 cubed is 2 times 2 times 2, that's actually 8. 27. And there it is. We already found our 64. I knew, I smelled that if they're going to give you a third root and say without calculator, it's probably got to be one of these. Okay, it's probably got to be one of these. Doesn't have to be, but it's probably. So you can continue that. And it's good to know these ones. They will come up a lot. 8's more common, but 64 is good too. 64 happens to be 4 cubed. Now, what about the negative? Well, because it's a cubed, negative 4 times negative 4 times negative 4 would give you negative 64. All right, again, third root, third power, cancel. That's the whole deal. Make sure you have a negative inside. But in the end, that's not going to matter because to the fourth power, that's going to end up as a positive 4 times 4 times 4 times 4 times 4, 256. Okay, and again, I cannot do that in my head. There's just no way. Okay. With a little bit of scratch paper, I can do it. And you want to make sure you follow the logic. I know it's a lot of rules. You got an exponent rule here. You got to, it's a bit like a puzzle. It's a bit like a puzzle. All right. Well, thank you for watching.